As in first part, I was talking about oxidation number, charge and valency. And there I not only explained the definitions of oxidation number or charge and valency, but I took some examples too and were very relevant in terms of IIT JEE and NEET. Now I'll keep on discussing there in the second part of that oxidation number or charge and valency. In this second part, in this second video, I'll be talking some more examples and even after discussing this all, even then too, if you have any difficulty, if you have any doubt, just please drop a message so that I can, in next video, I can cover all those examples too, other than what I am going to take. Now see, in first part, I took a Fe3O4 and there I told you that Fe3O4 is ferroso-ferric oxide, or you can say iron 2,3 oxide. It's a mixed oxide. It is not pure oxide. See, their iron was showing 2 plus and 3 plus oxidation state according to exact method, and according to average method it will be showing 8/3. That will be the average oxidation number of Fe. But if you see the individual or exact oxidation number of two different types of Fe, then it will be 2 and 3, 2 plus or 3 plus. But according to average method, it will be 8/3. Now like that, I'll be talking about further about Pb3O4. It looks similar to Fe3O4, but is not similar to Fe34. It is not made of PbO plus Pb2O3. Why it is not made of PbO and Pb2O3? PbO is fine. What about Pb2O3? In this case, Pb will be showing 3 plus oxidation state, which lead can't show. So this won't be the right one. It's a mixture of PbO plus PbO2. This will be twice PbO. Now see Pb3O4. Here this Pb is 2 plus charged and this Pb will be 4 plus charged. As we know, carbon and family members can show 2 plus and 4 plus oxidation states. Upper members, their stable oxidation state will be 4 plus, and lower members having atomic number 50 or more than 50, their oxidation number more stable will be 2 plus. Reason is inert pair effect. Reason is inert pair effect. So this Pb3O4, their Pb will be showing 2 plus and 4 plus oxidation state. And if we calculate this by average method, then 3x minus 8 again will be 0. So x will be equal to, x will be equal to 8/3. So all these examples are very important. What my experience is there in previous years IIT JEE NEET, whatever examples, whatever questions they may be asking you or they have already asked you will be there from all these examples which I have discussed there in my first video and in discussing there in the second. And if you will be taking interest in this all, then I'll be making third video also. So from these 3 videos, I hope so that if they will be asking you any question from oxidation number, charge or valency, must be from these 3 videos, from these 3 examples which I will be discussing there in these 3 videos will be there. Now see, I'll keep on discussing some more examples. N3H. What this is? This is hydrozoic acid. What this is? This is hydrozoic acid. What N3, if we'll take out H from this N3H, what we will get? N3 minus. What this N3 minus is? Azide ion. See, again two methods are there. According to one method, 3x is equal to -1. 3 atoms of nitrogen are having 1 minus charge, so 3x is equal to -1. So x will be equal to -1/3. This is average method. What this is? This is average method. This is average method. Now see what this N3 minus is. This N3 minus means N minus plus N2. In N minus, what is the oxidation number of N? In this N minus, oxidation number of N is -1, and as I have already told you, element there in their elemental state, atoms there in their elemental state will always show 0 oxidation number. So here oxidation number shown by nitrogen there in N2 will be 0. So what oxidation states this nitrogen will be showing there in N3 minus? 0 and -1. This is exact method. This is the modern method, and this is mathematical method, average method. That is not the exact one. That is not the correct one. But see, if 0 and -1 is not given, then -1 by 3 will be the answer. But if -1, 0 and -1 by 3 is given, and it is single choice question, then since this is the most modern method, so answer will be 0, -0 and -1. Answer will not be -1 by 3. But if 0 and -1 is not given, then the answer will be -1 by 3. And if it is multiple choice question, then you will be writing all -1 by 3, 0 and -1. So it depends that what options they are going to give you. Now see, I'll take one more example to elaborate this further. See Ki3. What Ki3 is? Ki3 is potassium superiodide. In this potassium superiodide, what I3 is? I3 is 1 minus. What I3 minus is? I3 minus means I minus plus I2. I minus plus I2. Here again the oxidation number shown by iodine is -1, and here it is 0. So this is the exact method. This is the exact method. And if you take the average method, then 3x is equal to -1. So x will be equal to -1 by 3. So we should know both methods, exact method and average method. Exact method you will be knowing if you know the bonding, then only you can handle that exact method. If you are not good in bonding, then it will be difficult for you to manage this exact bonding. But average method, that their bonding is not required, just that maths is required. Now see, this all is over. Now see Br3O8. What oxidation number, what charge these three bromine atoms are having? Average method, 3x minus 16 is equal to 0. So x will be equal to 16 by 3. That's average method. What exact method is? Br. There you should draw the structure. That's there in your NCERT redox reaction chapter. There it is there. This topic you know is from redox reaction now, oxidation number, and will be used there in almost every part of chemistry, whether it is 11th or 12th, whether it is organic, inorganic or physical, whatever it is. Now see here, the oxidation number of oxygen, oxidation number or charge of oxygen is -2. This is -2, this is -2, this is -2, so this will be 6 plus. Now you will ask me why I have not taken this Br, because Br, I, SS, PP, NN, there, if one atom is attached with another similar atom, then the charge will always be 0. Charge will always be 0, except in peroxide. There this will be -1 and this will be -1. Their oxidation number will be minus. So in peroxide, that is exceptional. In remaining all cases where similar elements are attached, then because of this bromine will be having 0 charge. Because of this will be having 0. Now see this Br. See, because of this Br and this Br will be having 0. This is -2, this is -2, so this Br will be 4 plus. Now -2, -2, -2, so +6, and this will be 0, so this Br will be 6 plus. So see, according to exact method, oxidation number of Br atoms will be 6 plus and 4 plus, but according to average method, it will be 16/3. So these two different methods are there. Now see, I'll take one more example, that is carbon suboxide. Carbon suboxide C3O2. Carbon suboxide. This is -2, this is -2, this is -2. So this will be +2 and this will also be +2. As I have already told, because of this carbon, this will be having 0. Because of this carbon, this will be having 0. And because of these two carbon atoms, this carbon atom will be having 0 oxidation state. So in carbon suboxide, that is C3O2, oxidation state shown by carbon is +2 and 0. What about the average oxidation number? C3O2. 3x minus 4 is equal to 0. So x will be equal to 4/3. This is average method. This is average method, mathematical method, and this is chemical method. This is exact method. So two different answers we will be getting there in all these different cases. Now see, Fe is always either 2 plus charged or 3 plus charged. But what about brown ring? What about brown ring? In brown ring, Fe is 2 plus charged. But whenever in Fe complexes NO is there, whenever Fe complexes are there with NO, then that NO will always be losing its 1 electron, will always be losing 1 electron. See, this NO will be losing 1 electron, so this Fe2 plus will get converted, this Fe2 plus will get converted into 1 plus. This Fe2 plus will get converted into 1 plus and this NO will become 1 plus charged. So this 1 plus and 1 plus, that is why it is 2 plus. Now see, Fe2 plus, what Fe2 plus is? Fe2 plus is 4s0 3d5. 4s0 3d5. So this Fe2 plus will be taking 1 electron, so that 1 electron will be going to 3d, and instead of 3d5 it will become 3d6. 3d6, what's the meaning of 3d6? 1 2 3 4 5. 1 2 3 4 5 and 6. Sorry, Fe2 plus is not 4s0 3d5, it is 4s0 3d6. So this will become 3d7. So how many unpaired electrons now this Fe will be having? 3 unpaired electrons. Since 3 unpaired electrons are there, so magnetic moment will be 3.8 bm. The magnetic moment of Fe there in brown ring will be 3.8 bm because it is having 3 unpaired electrons. How it is having 3 unpaired electrons? Because this Fe2 plus is 4s036 and this NO will lose its 1 electron. So 3d6 will become 3d7. From that point of view, it is having 3d7 configuration. Don't write that Fe1 plus directly. If we'll write Fe1 plus directly, then electronic configuration you will be getting will be 4s1 3d6, and from this point of view it will be having 5 unpaired electrons and magnetic moment will be 5.8 bm, but it is not so. It is not having 5.8 bm magnetic moment. It is having 4s0 3d7. So I have explained you this. So this is about the oxidation number shown by Fe there in brown ring. This is about the magnetic moment of Fe there in brown ring. Now see, I'll explain you some, I'll take some more examples so that I can make you understand this oxidation number. See what Prussian blue is. Prussian blue. What Prussian blue is? Prussian blue is Fe4 FeCN whole 6 3. This is Prussian blue. Now see, this is 2 plus charged. How many Fe you have taken? See how many Cn are there? 6 3s are 18. So it is 18 minus. Now see, if this is 2 plus, either this will be 2 plus or this will be 3 plus. If one will be 2 plus, then another will be 3 plus. If you will take this as 3 plus, so 3 plus into 3 will be 9 plus. And then this will be 2 plus, and 2 plus 8 will be 8 plus. So 8 plus 9 plus will not be 18 plus, it will be 17. So won't be correct. So this is 2 plus. So 2 plus and 3 will be 6 plus. This Fe is 6 plus. This is 2 plus. So since this is 2 plus, so this will be 3 plus. This 3 plus into 4 will be 12 plus. So C 12 plus and 6 plus will be 18 plus, and this is 18 minus. This is Prussian blue. This Fe, which is outside the square bracket, will be ionizable, and this Fe2 plus, which is inside the square bracket, won't be ionizable. So this will not be giving test of Fe2 plus. This will be giving test of Fe3 plus ion only, because that 3 plus is ionizable. Why it is ionizable? Because it is ionically bonded, it is electrovalently bonded, and this Fe is coordinately bonded. Dative bond is there, which is non-ionizable, and ionic bond is ionizable. Now see, this was Prussian blue. What about Turnbull's blue? What about Turnbull's blue? So it is easy for you to remember. Turnbull means keep this 2 plus outside and Fe3 plus inside. That is what the meaning of Turnbull is. Fe2 plus, then Fe3 plus, and Cn whole 6. This is 6 minus, this is 3 plus, this is 2 plus, so 5 plus, so this will be having 1 minus charge. So here this will be giving test of Fe2 plus and will not be giving test of Fe3 plus. Why? Because that Fe3 plus is inside the coordination sphere, inside the square bracket, which is not ionizable, and Fe2 plus is outside the square bracket, that is ionizable. So we'll be giving test of Fe2 plus. So this is all about the oxidation number or charge and valency. See, I have already told you so many examples in which sulfur is involved are there and was there in IIT-JEE or NEET exams. So what examples you will be asking me there in doubts, from there I'll get an idea, and in this way this topic from your life will get over. Nothing else they can ever ask you related to all these different oxidation number, charge and valency. Fine. Thank you very much. Thanks all of you. Thank you very much.